Hello guys, welcome to Crown Smart. In this video, I want to talk about inverse of a matrix. So given a matrix A, which is a 2 by 2 matrix, we want to find the inverse of a matrix. This time around, I want to find the inverse of a matrix using Gaussian elimination method to do it. Okay, now, before I start, of course, to find the inverse of a matrix, which is very easy, you need to first of all find the determinant. Okay, before I use the other method, we need to find the determinant. Of course, in a 2 by 2 matrix, finding determinant is 1 times 4 minus 3 times 2. Okay, so the determinant here is going to be 1 times 4, which is 4, minus 3 times 2, which is what? 6. So 4 minus 6 is minus 2, right? So that's the determinant. Then the next thing we are going to do is to, now looking at this leading diagonal, I'm going to switch these values. So this is going to be 4, 1, and here I'm going to multiply these two by minus 1. These two values, or these two entries, I'm going to multiply them by minus 1. So I have minus 3 minus 2. Then multiply this result by 1 over the determinant. So multiply the result by 1 over minus 2. And of course, this is actually what? A inverse. Okay, so this is going to be, if you watch, this is going to be, if you multiply this inside, you're going to have minus 2. Okay, here you're going to have 1. Here you're going to have 3 over 2. And here you're going to have minus half. So this forms your what? Your A inverse. But this, actually I did this method so that when we now use Gaussian to form our inverse, we'll now compare and see whether it is going to give us the same thing. Okay, so now let's solve it the other method, which is the Gaussian elimination method. Now for us to find the inverse of this matrix, now what I will need to do is, first of all, now if this is the matrix 1, 2, 3, 4, I will draw a line here after writing my 2 by 2 matrix. Then what I will now write on the other side here is going to be the identity matrix of a 2 by 2 matrix, which is 1, 0, 0, 1, and I close it. Now what I'm going to do next is to make sure that whatever I have here must look exactly like this. Okay, so my job is to transform all these values to this, okay, to an identity. So to do this, I'm going to use Gaussian elimination method to do this. Okay, now watch. Now before we start, we know that this is your row 1 and this is also your row 2. Now if this is your row 1 and this is your row 2, of course we have something we call the leading variable. Now the leading variable is the first non-zero value in a row. So if we are looking at the row 1, what is the leading variable for this row 1? Is 1, because 1 is the first non-zero value in a what? In a row. So I'm going to take 1 as my leading variable, and I'm going to make here to be what? 0, so that it will look like this. So I'm going to, once this is my leading variable, I will make this one to be what? 0, so that it will look like what? The identity. Okay, so since this is my leading variable, I'm going to rewrite this again as 1, 2, 1, 0. Reason I'm writing only this is because I want to eliminate this. I want to solve for new values for this second row. So my row 2 is equal to, now since this is my leading variable, now the idea here is, what will I multiply to 1 and add to 3 to give me 0? So if this 1 is my leading variable, what will I multiply to that 1 and add to 3 to give me 0? Now of course you can multiply, if you multiply minus 3 here and add to 3, you're going to have what? 0. So this is going to be minus 3 plus 3 will give me 0, right? So this is minus 3. Now where is this my 1? My 1 is in the row 1. And where is this my 3? My 3 is in the second row, right? So this has formed a row operation. So this is going to be minus 3 row 1 plus what? Row 2. Okay, so I will use this row operation to fix in the values here. Okay, of course here is going to give me 0. Now minus 3 times row 1 plus row 2, that is minus 3 times 2. Please, minus 3 row 1 means minus 3 times all the entries in what? Row 1. Okay, so minus 3 times 2 is minus 6. Now minus 6 plus 4 is minus 2. Okay, now minus 3 times 1 is minus 3 plus 0, minus 3. Of course, minus 3 times 0 is 0 plus 1, 1. Okay, you see that I've achieved the 0, right? I've achieved this 0, which is this. Now the next thing is to also find this part, to make this part 0, which is here. I'm going to make this part 0. So since I'm done with this, since I've made this to be 0 and this is under the leading variable, I will now come down to the second row and look for the first non-zero value. The first non-zero value is minus 2. So minus 2 is now the new leading variable. So I will use this leading variable and make any value. Since this is the leading variable, I will now make 2 to be what? 0. Okay, now remember, if this is a leading variable, then any value under it or above it must be what? 0. You not actually must be 0. You use this leading variable to make those value under it or anyone above it to be what? To be 0. So since minus 2 is now the leading variable, I will now find, okay, let's rewrite it first before we now do something. So 0 minus 2 minus 3 1. Okay, so I want to fit in a new values here. So what happens here is this is going to be row 1 is going to be, now to find the operation, what will I multiply to minus 2 and add to 2 to give me what? 0. Now if this is minus 2, what will I multiply to minus 2 and add to 2 to give me 0? The answer is 1. So that means if I bring out this 1, where is minus 2? Row 2. Where is the 2? Row 1. So this forms my what? Operation. So therefore row 1 is equal to 1 row 2 plus row 1. Okay, 1 row 2 plus what? Row 1. So meaning that if I should do 1 times row 2 plus row 1, I will have, that is 1 times 0 is 0 plus 1 will be 1. 1 times minus 2 is minus 2 plus 2 is 0. 1 times minus 3 is minus 3 plus 1. So minus 3 plus 1 will give me what? Minus 2. And 1 times 1 is 1. Okay, 1 times 1 is 1 plus 0 is going to give me what? 1. Okay, now you see that I've achieved this 2 to become what? 0. Now observe that in your identity matrix we have here to be 1. So here is already 1. So there is nothing. So we leave it like this. Okay, we have achieved this one also. So the next thing is to make this side 1, which if you look here now, you see that this is minus 2. So how do I achieve this? Now to achieve this, what happens is we write this thing again, minus 2 1. Now the row operation I'm going to perform here is going to be, since this is row 2 will now be what? What will I multiply to minus 2 to have 1? If this is minus 2, what will I multiply to minus 2 to have 1? It is minus 1 over 2. So minus minus becomes plus. Now 2 cancel 2, you have what? 1. So row 2 is minus half row 2. Okay, so minus half times all the entries in what? Row 2. So this is going to be minus half times 0, 0. Minus half times this is going to be what? 1. Minus half times this is going to be 3 over 2. Minus half times this is going to be what? Minus half. Okay, now you see that I have formed the what? I have formed the identity matrix on this side. Okay, now meaning that whatever result I have here is what? The A inverse. So therefore my A inverse is equal to the matrix minus 2 1 3 over 2 and minus half. Okay, so you see that this is how you form your what? the inverse of a what? A matrix. Now observe that using the first method was easier, right? Because it is a 2 by 2 matrix. But the truth is that using this Gaussian eliminator using this method will help us if we are doing a 2 by 3 by 3 or a 4 by 4 matrix. It is much more easier using Gaussian in doing a higher matrix like 3 by 3, 4 by 4. Okay, but if we're given a question, I think the other method in finding the A inverse in terms of a 2 by 2 matrix is much more easier. Okay, thank you. So I hope you really understood this. Please try and subscribe, and also like and share to your friends. Thank you.